What are we looking at here? That concept has gone from paper to reality. I'm talking about the launch tower that China has copied from SpaceX. It's now complete. China's biggest ambition may be to outpace SpaceX, but will it really be that simple? Their tower design appears to carry significant risks, and their copying efforts won't stop there. CAS Space is also making progress with their Kinetica rocket. Let's dive into these updates on today's episode of Great SpaceX. In previous episodes, I discussed Cosmosleap's ambitious plan to replicate SpaceX's innovative Starship launch catch tower system. Since then, the company has made significant strides, securing funding to support the development of their own launch tower and rocket, LEAP, also known as Yueqian. Now, that vision has moved from concept to reality. Recently, videos shared on the platform X showcased China's completed launch tower, which mirrors the design Cosmosleap had previously presented in 3D concept animations. This may be China's most accurate replication of SpaceX's system to date. Like SpaceX's tower, it features a modular steel frame structure and the chopstick system, designed to lift, lower, close, open, and rotate around a booster, nearly identical to SpaceX's setup. At first glance, the tower's similarity to SpaceX's design might raise questions about its authenticity. However, it's entirely real. Cosmosleap confirmed several critical technical developments in prior funding updates, including a chopstick clip tower recovery verification platform, a flight control computer named Firestone No. 1, and China's first domestically produced tower recovery controller, Little Firestone. The rapid progress Cosmosleap has demonstrated is remarkable, especially considering that the company, officially known as Haolong Yueqian, was only founded in March of this year. Reaching the current development stage in just a few months is unprecedented, underscoring the efficiency and speed of China's replication approach in aerospace. Now that the tower structure is complete, Cosmosleap will likely channel its efforts and resources into completing other vital subsystems. These include the launch mount, which secures the rocket before liftoff, and the tank farm, which will fuel and supply the rocket's propellant. Alongside this, work on the LEAP rocket itself is expected to accelerate. If Cosmosleap maintains its current pace, a launch and landing attempt could be possible as soon as next year. China's aerospace sector, and companies like Cosmosleap in particular, benefit from considerable government support. This backing allows them to move forward without the environmental or public safety constraints that frequently delay U.S. companies. This freedom from restrictive oversight enables rapid, unfettered development at an impressive pace. In any case, SpaceX, a leader in the global aerospace industry, has become a focal point of imitation, especially in reusability and cost reduction efforts. Beyond Cosmosleap, many other Chinese rockets from private firms and state organizations alike reveal SpaceX's influence in their designs, particularly the newer versions of the Long March rocket family. This trend aligns with the analysis from Polaris Dawn mission commander Jared Isaacman, who tweeted about the strategic importance of SpaceX's advancements. He pointed out that Starship's rapid reusability and other capabilities, such as orbital refueling, represent a revolutionary leap in space capabilities. The high ground has always mattered, Isaacman remarked, noting the value of these advancements in military, economic, and exploratory terms. He emphasized that these developments are impossible to ignore for the United States and certainly not for China. This escalating dynamic raises significant concerns for the U.S. aerospace sector. While China's government-driven model allows rapid progress, the U.S. regulatory environment can act as a brake on momentum. In particular, complex government procedures and layers of oversight often cause delays. Chief among these barriers is the Federal Aviation Administration, the body responsible for licensing rocket launches in the U.S. Its detailed review, investigation, and assessment process can take months. Additionally, environmental agencies frequently intervene under the guise of environmental protection, a valid priority but one that can sometimes overlook the strategic and competitive value of rapid aerospace advancements. SpaceX has encountered many of these regulatory challenges, particularly with its Starship project. Delays before Flights 2 and 5 serve as reminders of these obstacles. Ironically, after finally approving Flight 5, the regulatory agencies admitted to errors in their previous assessments of SpaceX's processes, acknowledging a lack of clarity that may have contributed to unnecessary setbacks. This illustrates the degree to which the U.S. regulatory landscape can inhibit progress, even as other countries are able to advance rapidly in similar technological areas. Despite these hurdles, SpaceX has achieved remarkable progress. In just a year and a half, with 5 test flights, they have accomplished several significant milestones, including the first vertical landings for Starship and catching the Super Heavy booster with the Mechazilla arms. However, to meet crucial upcoming goals, such as the Artemis 3 lunar mission in 2026 and the Mars colonization mission that follows, SpaceX will need to increase its development and launch frequency even further. Reforming agencies like the FAA to streamline their processes and reduce delays could play an essential role in accelerating SpaceX's timeline. If you agree that U.S. aerospace innovation should be prioritized, comment "Let SpaceX fly" and share your thoughts. And as always, be sure to like, share, and subscribe to stay informed on SpaceX's exciting journey toward a future where humanity can explore new frontiers in space. Now, when we consider the technological aspect, it's clear that China's attempts to replicate SpaceX's innovations won't be enough. Copying the outer design doesn't mean mastering the underlying technology, a gap visible in Cosmoleap's recently unveiled launch tower system. To begin with, the structure of Cosmoleap's chopstick arms appear unbalanced. The arms are longer than SpaceX's, making them more cumbersome and increasing operational risks. Strangely, these arms are paired with a medium-lift rocket roughly the size of a Falcon 9, which seems mismatched with such a large setup. Furthermore, their launch tower appears low and lacks a launch mount underneath, which may complicate tasks like stacking and launching. Perhaps the most concerning factor, however, is the tower's location. Based on videos, Cosmoleap's tower was constructed alarmingly close to residential buildings. This follows a common pattern in China's aerospace strategy, where facilities are often built deep inland and near populated areas, an approach that has garnered widespread criticism for safety concerns. There have been numerous incidents in China where rockets have come dangerously close to residential areas. Earlier this year, for example, a Long March 2C booster crashed near a populated area, releasing toxic gases. More recently, a test failure of the Tianlong 3 rocket caused significant vibrations felt near residential zones, even from a considerable distance. Though China's reports often state that no injuries occurred, the risks posed by these incidents remain high. With Cosmoleap's new launch tower so close to residential areas, potential hazards such as vibrations, fuel venting, debris, or even catastrophic explosions could pose serious threats to public safety. Additionally, the question arises, how will Cosmoleap expand its infrastructure in such a densely populated area? Demolishing neighboring zones isn't a viable long-term plan. In contrast, SpaceX situated its Starbase launch tower in a remote area along the southern Texas coast, far from major populations. Yet, they continuously face regulatory delays from U.S. government agencies. If Cosmoleap's tower were held to similar U.S. safety and regulatory standards, it's likely it would never be approved for use. Observing Cosmoleap's rapid, risk-laden growth highlights a stark difference between their approach and SpaceX's model of sustainable, regulation-compliant expansion. Chinese companies may indeed grow quickly, but without strong foundations and adherence to long-term safety standards, they risk facing critical failures. Such incidents could lead to shaken investor confidence, potentially causing projects and even entire companies to collapse just as quickly as they grew. This, ultimately, is why these copycats are unlikely to ever surpass SpaceX. However, their ambitions persist. In addition to Cosmoleap's developments, another Chinese company, CAS Space, is also making strides with its own rocket advancements. At 11:03 p.m. UTC, or 6:03 p.m. Eastern Daylight Savings Time on November 10th, CAS Space launched its Kinetica 1, or Yueqian 1 rocket from the Yueqian Satellite Launch Center, deploying 15 satellites into orbit, including the Jinlin 1 satellite for Changguang Satellite Technology, or CGST. The launch took place in the Dongfeng Commercial Space Innovation Test Area, an area reserved for Chinese commercial aerospace companies, many of which are emulating SpaceX's models and methods. This launch marks Kinetica 1's third mission this year and the fifth since its debut in July of 2022. Standing 30 meters tall with a 2.65 meter diameter, Kinetica 1 is powered by a solid rocket engine, has a liftoff thrust of 135 tons, and can carry payloads of up to 1.5 tons to a 500-kilometer sun-synchronous orbit. This launch series is part of CAS Space's preparation to transition to the Kinetica 2, slated for September of 2025, with upgraded capabilities, which include 7.8 tons to SSO and 12 tons to low Earth orbit. By late 2026, 2026, the company aims to achieve full reusability for Kinetica 2, likely adopting grid fins, landing legs similar to Falcon 9, and possibly methane fuel like SpaceX's Starship. The ultimate goal is the Kinetica 3, capable of launching 20 tons to SSO, and is fully reusable. CAS Space is ramping up its launch frequency and plans to schedule 5 to 8 flights annually once Kinetica 2 is operational, with ambitions to serve international customers thereafter. Despite these ambitious plans, numerous attempts to replicate SpaceX's approach have failed. Time will reveal what lies ahead for CAS Space, Cosmosleap, and other ambitious imitators in China's aerospace sector. From ground systems to rockets, and from private to government sectors, it's clear that China is taking cues from SpaceX in nearly every area. Their latest and most ambitious endeavor is the Long March 9, said to be China's most powerful launch vehicle yet, inspired heavily by SpaceX's own designs. With this new rocket, China aims to achieve bold milestones, including advancing in the lunar race. Meanwhile, NASA's systems are grappling with mounting challenges, underscoring the critical role of SpaceX and Starship in helping NASA stay ahead and counter China's strategic ambitions. So just how powerful is China's new rocket, and how will SpaceX outmaneuver these so-called imitators? You may recall that I mentioned a notable Chinese rocket design that closely resembles SpaceX's Starship, the future iteration of the Long March 9. Soon, this model will make its debut. According to Science and Technology Daily, China will showcase it at the Zhuhai Air Show on November 12th. Alongside the Long March 9, the event will also feature the Long March 10A, the initial version of their lunar rocket. Long March 9 is set to become China's largest rocket, far exceeding the current Long March 5, which stands 27.6 meters tall with a 3.5-meter diameter. In comparison, Long March 9 will be a massive 114 meters tall with a diameter of 10.6 meters. This rocket will be powered by 30 YF-215 engines, each producing 450,000 pounds or 200 tons of thrust, for a total liftoff thrust of 13.5 million pounds or roughly 6,000 tons. The reason it's often called a Starship copy lies in the recent design revisions. Currently, Long March 9 is an expendable model with up to 4 optional side boosters, each 5 meters in diameter. However, the future version of this rocket will adopt key Starship-like features, most notably a reduction from 3 stages to 2 and the addition of flaps for controlled descent. These updates will enable reusability, while the YF-215 engines will switch to methane and liquid oxygen, just like SpaceX's Raptor engines. With these mimicry tactics, China is moving forward with confidence in its ambitious plans for the Long March 9. Once operational, the Long March 9 is likely to replace China's current rocket lineup for key missions, such as resupplying the Tiangong space station. While some believe a rocket of this scale is unnecessary, Tiangong is expected to expand in the future, accommodating more astronauts, which will ultimately necessitate a larger launch vehicle. Beyond Earth orbit, the Long March 9 is seen as a pivotal asset for China's lunar ambitions. Although the Long March 10 is planned for crewed lunar landings, the Long March 9 will handle the transport of modules and other infrastructure needed to establish the ILRS lunar base in the early 2030s. And following lunar operations, it's likely this rocket will be adapted for Mars missions, especially if it evolves into a Starship-like model with reusable capabilities. Such a version would enable China to undertake extended missions to Mars quickly and at reduced costs. China may also mirror SpaceX's groundbreaking approach to rocket recovery. A private Chinese company, Cosmosleap, has already introduced a catch system for their LEAP or Yueqian rocket, which could potentially be adapted for the Long March 9. Although Cosmosleap is considered private, it appears to have significant state backing, so integrating their technology would likely be straightforward. The Long March 9 is projected for its first launch in 2033, marking a new chapter in China's space capabilities. As China's space program accelerates, largely due to unconventional strategies, NASA's approach appears increasingly passive by comparison. Although the Artemis 1 mission launched successfully in 2022, it required substantial time and funding, resources that are now being poured into Artemis 2. However, progress remains slow. Only recently did NASA transport the first components of the SLS to Kennedy Space Center, and with less than a year until Artemis 2's scheduled launch, the rocket is still not fully assembled. This raises significant concerns about when critical testing will even begin. The Orion spacecraft itself faces notable challenges, especially with its heat shield. After years of investigation into heat shield issues, NASA finally identified the problem, but has kept further details under wraps. It's still unclear whether they'll replace the heat shield entirely, which could further delay the mission. Alongside this, repairs to the mobile launcher system after Artemis 1 have taken considerable time, and recent reports from the GAO raise cost concerns and cast doubts on the exploration ground system's readiness. Looking ahead, other elements of the SLS program also face scrutiny. The Boeing-built Exploration Upper Stage, or EUS, and core booster for the SLS Block 1B model are reported to have quality issues, further escalating costs and pushing timelines back. Compounding these issues, NASA continues to allocate funds to new projects with uncertain futures. The Viper rover, once heavily funded, was recently considered for cancellation despite nearing completion. Likewise, the Lunar Gateway project raises questions about compatibility with Artemis components, particularly the Starship HLS. In the face of these challenges, it's clear that NASA needs a more streamlined, solution-oriented approach to maintain competitiveness in the new space race. My point is not to praise China while underestimating NASA. However, based on recent developments, it's difficult to feel confident that NASA can easily outpace China in the current space race. The next critical milestone for NASA is the Artemis 2 mission, and the question remains, will they launch on time, and will the mission succeed? Only time will tell. But fortunately, NASA's program still benefits from the inclusion of SpaceX and its groundbreaking Starship. Also, in October, Starship completed its 5th flight, Flight 5, marking a notable achievement as SpaceX successfully caught the Super Heavy booster with the Mechazilla arm. This progress has positioned SpaceX on track for Flight 6, currently set for November 18th, a full year after Flight 2. Flight 6 will include another Super Heavy catch, an in-space engine relight, and a heat shield test, all paving the way for key advancements in 2025. Next year, we can expect SpaceX to further refine Starship's recovery capabilities by catching the ship itself, marking a major milestone toward full reusability. Achieving a full reusable rocket will allow SpaceX to launch at a quicker pace and lower cost, an edge that China is actively trying to emulate. In addition, SpaceX is likely to debut the updated Starship V2 as part of these advancements. By March, SpaceX plans to establish an orbital refueling system, significantly enhancing Starship's mission flexibility. With this infrastructure, flights will become more frequent, and Starship will be prepared with in-space refueling capabilities well ahead of Artemis 3. SpaceX's ground operations are also ramping up. The Star Factory has begun production, enabling faster hardware manufacturing. As evidenced by the swift stacking of S-33 within 41 days, production speed is only set to improve from here, further accelerating SpaceX's progress. Meanwhile, SpaceX is steadily advancing its testing and launch infrastructure. The integration of the Flame Trench has shown significant efficiency, and the construction of additional launch pads and prototypes is aimed at further boosting launch frequency. This expansion is not limited to Starbase alone, as the Starship system is likely to extend to Florida as well. In terms of the lunar program, SpaceX has made strides with subsystem testing. Recently, the company unveiled the interior design of the HLS nose cone, showcasing unprecedented potential for lunar missions. And while China has yet to replicate the current Starship, SpaceX is already on the verge of introducing a new iteration, complete with upgraded hardware and engines. This next-gen Starship promises a colossal 10,000 tons of thrust, solidifying the US's position in the space race and casting a long shadow over China's efforts. With each success, SpaceX is demonstrating its readiness to meet the Artemis 3 schedule, even if delays occur in the earlier stages. A timely, successful Starship launch for Artemis 3 would deliver a decisive edge over China's ambitious plans. It's worth noting that many Chinese SpaceX replicas have faced setbacks, underscoring SpaceX's lead in this competitive field. The stage is set for a groundbreaking showdown in the new space race. On one side, we have an industry leader driven by relentless innovation and the goal of multiplanetary existence, and on the other, an ambitious competitor whose rapid progress and willingness to adapt rival that of the Soviet Union in the last century. Unlike the original space race, this competition has multiple layers, testing the limits of technological ingenuity, geopolitical strategy, and the drive to secure dominance in the final frontier. China's accelerated pace and keen adaptability are making them a formidable rival, their incremental advancements strategically placing them closer to key milestones, such as a lunar landing and plans to establish a lunar base. The unveiling of their Long March 10A rocket and plans to launch taikonauts to the moon by 2030 underscore a focused and rapidly advancing agenda. Meanwhile, SpaceX, led by its flagship Starship, has achieved remarkable strides. From rapid prototyping and high-frequency testing to the ongoing iteration of hardware and mission profiles, the company has maintained a lead that feels increasingly insurmountable. Starship's continuous evolution, including in-orbit refueling, advanced heat shield systems, and reusability upgrades, positions it as a powerful asset in America's strategy to regain space leadership. The upcoming years will be decisive. Should SpaceX meet its ambitious target of returning astronauts to the moon by September of 2026, it could signify a pivotal win in the era's space race. The outcome would not only affirm SpaceX's dominance, but also set the stage for humanity's next chapter in space. What's your take? Can SpaceX secure a victory and effectively end this race on top? What's on the agenda for Flight 6? The flight timeline has been released, revealing a significant update, a new heat shield marking a major milestone for the future of Starship. Meanwhile, any health concerns for the Starliner astronauts have been cleared, with their health officially confirmed as stable. As we mentioned in the last episode, Flight 6 is now right around the corner. True to earlier predictions, this upcoming flight will feature significant updates in Starship's progress, including a crucial new task, reigniting the engine in space, a test essential for future missions involving orbital refueling and long-range trips to the moon, Mars, and beyond. But that's not all. There's an equally critical aspect being tested this time. S-31's heat shields won't be fully installed. According to SpaceX, several thermal protection experiments and operational changes will test the limits of Starship's capabilities and generate flight data to inform plans for ship, catch, and reuse. The heat shield configuration on this flight is a major shift, and SpaceX will use it to assess new secondary thermal protection materials. Notably, entire sections of heat shield tiles have been intentionally left off on both sides of the ship in key areas under study for catch-enabling hardware on future vehicles. These tile-free areas are located around the forward flap, where images show the heat shield absent near the body's connection to the flap. This change could support new catch hardware, possibly functioning similarly to a lifting point as a primary or secondary support for the catch process. Imagine a foldable system that could flexibly open and close, simplifying integration with the chopsticks for a smoother and more secure catch maneuver. SpaceX has hinted that there could be additional zones with similar configurations, possibly further down the ship. It's a fascinating setup that may provide essential insights into materials and designs for future fully reusable starships. As SpaceX continues to refine Starship, these tests will help shape the path to reliable reusability and frequent, cost-effective launches. With these enhancements, SpaceX is moving closer to achieving a rapid, reusable launch system. But this mission is also a giant leap forward for gathering data, advancing heat shield technology, and perfecting the catch mechanics that will eventually bring Starship back to land ready for a quick turnaround. What might these new configurations mean for future missions? Could other sections of the ship eventually see similar designs? Feel free to share your theories in the comments section down below. By removing sections of the heat shield, SpaceX can achieve multiple testing objectives. First, it will evaluate the performance of the ablative layer, introduced on Flight 5, which Elon Musk has said could make the heat shield twice as robust. Additionally, exposing these areas to re-entry conditions without heat shields will reveal their durability. SpaceX notes that if these sections are used in the catching system, they'll be unshielded, making this test essential for refining the new system's design and integration. SpaceX also mentioned a modification to the landing approach, specifically adjusting the landing angle with a steeper angle of attack. This requires a higher load on the flap systems, pushing them to new limits. Data gathered here will inform future landing configurations. Another advantage of this flight is the timing. It's scheduled for late afternoon at Starbase, which means the ship's landing trajectory will occur in daylight over the Indian Ocean. This will provide a clearer view of the descent path, though it may diminish the visual impact of the plasma effect during re-entry, which is usually more striking against a night sky. As Flight 6 approaches, SpaceX has ramped up preparations. A new road closure schedule has been issued to support the rollout, November 11th from 7 p.m. to 10 p.m., and November 12th from 10 in the morning to 1 in the afternoon, for moving Booster 13 to the launch site. Following a few weeks of static fire testing, critical systems like the engines, chains, and grid fins are expected to be fully checked. This rollout might also feature hot staging. Once Booster 13 is in place, Ship 31 will likely follow soon after, ready for pre-flight integration and final heat shield adjustments. Preparations are well underway for the world to witness the next Starship flight, featuring some thrilling changes and exciting milestones. Type in "I'm ready" in the comments section if you're gearing up for this mission, and don't forget to like, share the video, and subscribe to our channel for ongoing updates on SpaceX's progress. SpaceX has also updated the flight sequence for Flight 6, though the overall steps and timing closely follow those from Flight 5. Before liftoff, the SpaceX flight director will conduct a thorough systems poll and confirm a go for propellant loading at T-1 hour and 15 minutes. Methane fuel loading will start at T-49 minutes and 50 seconds, followed by the engine chill at T-19 minutes and 40 seconds, ensuring that the engines are at the right temperature for optimal performance. Propellant loading for both the ship and booster will complete at T-3 minutes and 20 seconds and T-2 minutes and 50 seconds, respectively, with the final go for launch being verified just 30 seconds before liftoff. As a minor change for Flight 6, SpaceX has opted to begin liquid oxygen loading on the ship and fuel loading on the Super Heavy earlier than in previous flights. This change will not drastically impact the timeline, but reflects continued fine-tuning of the pre-launch sequence. As the countdown continues, 10 seconds before liftoff, the flame deflector system will engage to direct the intense heat and force of the engines away from the launch pad. The engines will ignite precisely 3 seconds before launch, setting the stage for another powerful liftoff. The changes to the launch sequence are minor, but they highlight SpaceX's ongoing refinement of its systems and procedures. The major addition to Flight 6 is the long-anticipated Raptor in-space relight demonstration, scheduled for T+37 minutes and 46 seconds. This critical milestone will occur roughly 10 minutes before Starship's re-entry, providing a unique opportunity to observe the ignition of Raptor engines in space. If SpaceX is able to provide camera views, this moment could stand out as one of the most exciting of the mission, demonstrating Starship's readiness for orbital maneuvers. The success of this test is pivotal, as it will enable future missions where Starship must perform in-orbit maneuvers such as returning to Starbase, launching payloads, developing an in-orbit refueling system, and eventually journeying beyond Earth's orbit to the Moon, Mars, and beyond. After liftoff, the sequence will closely mirror Flight 5 with slight timing adjustments. Starship will reach max Q at T+1 minute and 2 seconds, and Super Heavy will experience MECO at T+2 minutes 32 seconds. Booster separation will occur at T+2 minutes and 39 seconds, using hot staging, followed by a boost back burn at T+2 minutes and 44 seconds, finishing at T+3 minutes and 38 seconds. At T+3 minutes and 40 seconds, the hot staging jettison will allow Starship to continue. By T+6 minutes and 25 seconds, Super Heavy will reach transonic speeds and begin the landing burn at T+6 minutes and 38 seconds, with engine shutdown at around the 7-minute mark. For Starship, after stage separation, the engines will continue firing until T+8 minutes and 27 seconds, when they will shut down. Starship will coast for 30 minutes, then perform the crucial in-space engine relight at T+37 minutes and 46 seconds, a key test for future missions. Starship's re-entry will begin at T+47 minutes and 13 seconds, lasting 15 minutes as it tests new heat shield modifications. At T+1 hour, 2 minutes, and 6 seconds, it will reach transonic speeds, followed by subsonic at T+1 hour, 3 minutes, and 12 seconds, before executing a landing flip at T+1 hour, 4 minutes, and 56 seconds. The landing burn will start at T+1 hour, 5 minutes, and 1 second, leading to a controlled vertical touchdown at T+1 hour, 5 minutes, and 24 seconds in the Indian Ocean. The daytime landing will be clearly visible, offering a thrilling moment. Flight 6 is set to showcase key milestones, including the Raptor in-space relight, heat shield tests, and landing sequence, all critical for Starship's future missions. Stay tuned for this historic flight. Now, let's turn to NASA's updates on ISS astronaut health, specifically regarding Suni Williams. Recently, media outlets like the Daily Mail and the New York Post stirred speculation about the health of NASA astronaut Suni Williams on the ISS, referencing a September 24th photo in which Williams appears gaunt, according to an external doctor's assessment. However, NASA quickly responded with a November 7th statement dismissing these concerns. The agency confirmed that Williams, who commands Expedition 72, is in good health and that they are not tracking any concerns, with her or any of the other 7 crew members aboard, which includes 4 NASA astronauts and 3 Russian cosmonauts. NASA reassured the public that all astronauts on the ISS, including Williams, undergo routine medical evaluations, have dedicated flight surgeons for monitoring, and are in good health overall. Williams and her fellow astronaut Butch Wilmore initially arrived at the ISS on June 6th via Boeing's Starliner spacecraft, intending for a brief 1-week stay. However, a malfunction in Starliner's thruster system extended their mission, leading NASA to bring the Starliner back uncrewed on September 6th. Williams and Wilmore will now remain aboard until February of 2025, at which point they will return alongside SpaceX's Crew 9 astronauts. NASA confirmed that the ISS has an ample supply of provisions for the crew, largely due to recent resupply missions, including the CRS-31 mission. With all essential needs met, the crew is set to complete their mission objectives and return home early next year. Unbelievable. What many once considered impossible, the Starship refueling system, will be demonstrated early next year, according to NASA. This is a challenging feat, yet SpaceX has every reason to be confident. The timing is critical as the US to enter a new presidential term, bringing with it ambitious plans for space exploration. Why is this mission happening so soon? How will SpaceX prepare? And how might the new administration impact the future of Starship? As 2024 winds down, we're on the threshold of the most monumental lunar mission in half a century. This time, humanity's return to the moon is enhanced by the power and potential of SpaceX's Starship, a spacecraft offering capabilities far beyond those of its predecessors. However, Starship's immense scale brings unique challenges. It lacks the capacity to reach the moon with a single load of fuel, making in-space refueling an absolute necessity to extend its reach to the lunar surface. The concept of a Starship refueling system has been under discussion for years, but questions about the timeline have persisted. NASA's deputy manager of the Human Landing System program, Kent Chojnacki, recently shared critical updates on the Starship roadmap for the coming year, including the timeline for its first refueling mission. Currently slated for March of 2025, this milestone mission is now just a few months away, a tight time frame given the hurdles SpaceX has faced recently. Regulatory delays significantly impacted Starship's progress earlier this year. For instance, more than 4 months separated Flights 4 and 5, primarily due to FAA evaluations and additional regulatory requirements. Continued delays of this magnitude could have put the refueling mission out of reach, as Starship would have required a stable platform for advancing its refueling capabilities. But Flight 5 marked a pivotal breakthrough, achieving 2 critical milestones: the first successful catch of the Super Heavy booster by the Mechazilla arm, and a controlled vertical landing of Starship itself. Additionally, the absence of new environmental or safety concerns this time around bodes well for regulatory approvals, potentially easing SpaceX's path forward. These accomplishments position SpaceX to conduct at least 2 more critical missions before March of 2025. The first, Flight 6, is scheduled for late 2024 or early 2025, intended to once again validate Super Heavy's capture and Starship's landing, reinforcing these techniques. Following this, Musk has outlined plans for another mission in early 2025, possibly in January or February, that aims to capture Starship itself after launch. This full recovery of both stages would signal the dawn of complete reusability for Starship, laying a solid foundation for in-space refueling development by March. The March refueling mission will be a defining moment. NASA has set 27 specific requirements for Starship to meet for lunar missions, and the refueling system is one of the most complex. This in-space ship-to-ship fuel transfer will demand an unprecedented level of precision. Encouragingly, SpaceX has already demonstrated the ability to move cryogenic fuel between tanks in flight, a capability tested during Flight 3 with the tipping point step that transferred fuel from the header to the main tank. For the upcoming refueling mission, SpaceX's initial objective will likely be to demonstrate basic fuel transfer between 2 ships. While this trial may not accomplish every intricate step required for the moon mission, it'll serve as a vital stepping stone, providing data and experience that will inform future developments. Following this demonstration, SpaceX will have over a year to refine and scale up the system to achieve the operational standards needed for sustained lunar operations. According to Cosmosleap, once Starship reaches a high enough launch cadence at Starbase, operations will shift to Florida, which could happen as early as late 2025 or early 2026. The prospect of the first in-space refueling mission is almost within our grasp, bringing a new era of space exploration closer to reality. Recent breakthroughs like Super Heavy's successful Mechazilla catch make the idea of refueling in space seem less like science fiction and more like a fast-approaching reality. The excitement builds with each milestone, pushing SpaceX closer to the moon and eventually beyond. Ready for this historic leap? If so, comment "ready" down below, and remember to like, share, and subscribe to stay connected to SpaceX's incredible journey. Before SpaceX can execute its first in-orbit refueling mission, there's a considerable amount of groundwork to complete. Successful refueling in space requires the simultaneous launch of at least 2 Starships, the primary mission Starship and a dedicated tanker. Both prototypes will need to be mission-ready well ahead of time. With SpaceX's ongoing transition to the V2 model, it's anticipated that these refueling Starships will also be V2, which brings a critical advantage: greater propellant capacity, making each refueling mission more efficient and impactful. SpaceX's production speed is encouraging. The first V2 model, Starship S-33, was built in a mere 6 weeks thanks to streamlined operations at the Star Factory and assembly bays. Currently, S-33 and S-34 appear to be standard Starships, so we're likely still waiting on the dedicated tanker variant. In addition to vehicle production, SpaceX is completing infrastructure upgrades, with Launchpad B set to be operational by the end of January. This timeline syncs well with the expected schedule for the refueling mission, ensuring that critical facilities are in place. However, this is only the beginning. The Starship prototype and Launchpad will both require ongoing development and refinements to meet the broader mission requirements ahead. SpaceX is also ramping up work on its Florida launch facility, the eventual launch site for the lunar-focused Starship HLS. The combination of Starbase and the Florida launchpad will enable an increase in launch frequency, an essential factor for consistent refueling operations and reliable lunar mission support. As SpaceX pushes forward, the upcoming test flights will be pivotal. Flight 6, though similar in objectives to Flight 5, will serve as a vital validation mission, further proving the booster's controlled landing and Starship's descent techniques. Consistent performance across these flights is key to building confidence in the system's reliability, especially given the operational pressures SpaceX faces with NASA's Artemis timeline. Following Flight 6, SpaceX is targeting one of its most challenging objectives yet, catching an orbital Starship after re-entry. Unlike the Super Heavy booster, which only requires a suborbital descent, Starship will need to navigate re-entry from orbit. This involves precision-guided navigation, careful deceleration, and the exact alignment necessary to meet the Mechazilla catch mechanism on the launch tower. While the controlled vertical landing in the Indian Ocean was a significant achievement, catching Starship on its return will require a higher degree of mastery over each maneuver. The combined efforts on these fronts are gradually laying the groundwork for SpaceX's in-orbit refueling ambitions and lunar exploration milestones. From upgraded infrastructure to refined landing and catching techniques, SpaceX is driving forward at full speed, making headway toward the realization of NASA's lunar goals and the broader vision of human exploration beyond Earth's orbit. Looking at the broader scope of space exploration, SpaceX's efforts are poised to provide significant support for NASA's mission continuity, especially as a new U.S. administration approaches. On October 30th, at the American Astronautical Society's Von Braun Space Exploration Symposium in Huntsville, Alabama, NASA Associate Administrator Jim Free emphasized the need to stay committed to the Artemis lunar exploration campaign. This initiative aims to return humans to the moon, setting the stage for eventual missions to Mars. "We need that consistency in purpose," Free stated. "That has not happened since Apollo. A shift in our goals would just take all our programs back." He continued, "We need to stick with the plan we have. That doesn't mean we can't improve, but we must keep a steady human spaceflight destination. Without this focus, we risk stagnation and other nations may surpass us. The space program has not been central in recent campaign discussions, yet both major political parties show a commitment to advancing U.S. capabilities in space. The Republican platform pledged to establish a robust manufacturing industry in near-Earth orbit, return American astronauts to the moon, reach Mars, and expand partnerships with the private space sector. In a recent speech, Donald Trump added, "We will land an American astronaut on Mars. Thank you, Elon. Get that spaceship going, Elon." Meanwhile, the Democratic platform, before Joe Biden withdrew from the race, outlined support for NASA's goals, including maintaining the International Space Station and sending Americans back to the moon and on to Mars. While each party may bring a distinct approach, both are committed to preserving U.S. leadership in space exploration. SpaceX's rapid advancements, particularly with Starship, provide a promising foundation for the U.S. to enter the next phase of this endeavor. In comparison to other systems, including NASA's, Starship is currently showing the most substantial progress. The roadmap from Earth to the Moon and Mars is clear, and SpaceX remains on track with its refueling plans, demonstrating this commitment. To keep pace, the incoming administration must address the regulatory delays that have impeded SpaceX's momentum. With multiple nations now joining the race for lunar dominance, timely action is essential for the U.S. to retain its competitive edge.
We would love to have, Elon would say next year he would love to have us have 25 missions a year. Wow. And in the next few years, 100. And the other day he was telling me, Kathy, I would love to launch a couple of times a day. So thank you. I don't know, big dreams.
Big dreams, right? 2025 is shaping up to be an exciting year, with Starship's launch rate expected to soar, as confirmed by Elon Musk and Kathy Lueders. Are you ready for it? Meanwhile, NASA has some intriguing plans in the works, including an extended cargo supply contract to the ISS and the launch of a new telescope. We're on the road to Flight 6, a mission that marks a critical step towards SpaceX's ambitious future. Initially, SpaceX proposed 25 Starship launches per year from Starbase, but delays from the FAA and environmental agencies temporarily stalled this plan. However, with the success of Flight 5 and potential regulatory reforms ahead, SpaceX is ready to get this plan back on track. As SpaceX Starbase General Manager Kathy Lueders mentioned, Elon Musk is aiming for 25 Starship launches per year, equating to one launch every 2 weeks by the end of next year. This ambitious cadence would lay the foundation for an even more audacious goal, scaling up to 100 launches annually, matching the current rate of Falcon 9 launches. Musk himself confirmed the goal, tweeting, "We will be much faster than that," signaling the company's intent to exceed expectations in launch frequency. Achieving 25 or more launches per year is vital for SpaceX to meet its long-term objectives. The frequency is essential for preparing for NASA's Artemis 3 mission in 2026, where Starship will transport astronauts to the moon. Beyond the moon, Starship's development is key to SpaceX's Mars colonization mission, with high launch frequencies ensuring that Starship will be ready for these monumental endeavors. In addition to the mission goals, SpaceX plans to achieve the catching of the ship, a significant milestone expected by April of 2025. This will be followed by the construction of a refueling system, which NASA expects to be operational by March of 2026. This system will enable Starship tanker flights, critical for lunar and Mars missions. Furthermore, achieving 25 launches per year at Starbase will pave the way for SpaceX's expansion to Florida, where the company plans to support NASA's Artemis program with an additional 44 launches annually. This expansion, combined with Starbase's high-frequency launches, will strengthen SpaceX's position as a leading force in space exploration. In short, reaching 25 launches per year is a crucial milestone for SpaceX, not just for operational readiness, but for its broader goals of lunar and Mars exploration. If successful, SpaceX will reshape the future of space travel and exploration, setting the stage for rapid, reliable missions to the moon, Mars, and beyond. But we all know this is just the beginning. Musk has consistently emphasized that faster, meaning 25 launches or one every 2 weeks, is not the ultimate goal. NASA has revealed that SpaceX must first achieve 1 launch per week, supported by 2 towers, before it can begin operations in Florida. Hitting 1 launch per week would result in over 50 launches annually. From there, the goal would be to double that number to 100, as Kathy Lueders mentioned, eventually escalating to multiple launches per day and ultimately reaching thousands of launches annually. This plan is essential for SpaceX to realize its vision of sending 1 million tons of cargo to Mars and establishing a city with 1 million inhabitants on the red planet. Achieving 25 launches per year by next year is a crucial first step toward that larger goal. In terms of frequency, this represents a 6-fold increase compared to this year, assuming Flight 6 is the last of 2024. This jump is a significant milestone for SpaceX, especially given the skepticism surrounding Starship's delays in 2024 due to regulatory hurdles and technical challenges. But SpaceX has been relentless in its pursuit of progress. To support this rapid acceleration, SpaceX is continuing to enhance its systems. Star Factory, the company's manufacturing facility, is now fully operational and proving to be highly efficient. The Starship stacking process, which once took months, is now down to just under 1.5 months. By next year, SpaceX aims to produce a Starship every week, and in the coming years, that pace could increase to 1 Starship per day, further ramping up production. SpaceX has also made substantial investments in its testing infrastructure. After acquiring the Massey gun range, the company upgraded its testing facilities, including a new flame trench system. This infrastructure is crucial for accelerating ship and super heavy testing, which is already progressing at an unprecedented pace, with the potential for even faster advancements. Regarding the launch site, SpaceX completed stacking Tower B in just 41 days and is now working on a new OLM design. The addition of 2 towers will significantly expedite both launch and recovery processes, with even more towers expected to appear at Starbase in the coming years to further increase the speed and volume of operations. As Kathy Lueders said, we are approaching 2025, a year when SpaceX's big dream will begin to come to life with Starship. The pace of innovation and launches will continue to accelerate just as Elon Musk has envisioned. If you're excited about this future, reply "Big Dream" faster in the comments, and be sure to like, share, and subscribe to stay up to date on SpaceX's thrilling journey. Next, let's discuss NASA's recent update regarding the extension of its ISS cargo supply contract. NASA has decided to extend its cargo contract to the International Space Station through 2030, aligning with the station's planned retirement. This decision was first outlined by the agency in March of 2023. According to procurement filings from November 8th, this extension will cover the period from late 2026 to late 2030, with Northrop Grumman, Sierra Space, and SpaceX continuing to provide cargo resupply services. This means the vehicles in use will remain Cygnus, Dream Chaser, and Dragon. These 3 companies were originally awarded the CRS-2 contract in 2016. Explaining the decision to extend the contract, NASA stated there are no other CRS-2 certified visiting vehicles in the current marketplace for providing cargo resupply to the ISS. Extension of the existing contracts is the most effective means of ensuring continued provision of these services for the extended duration of the ISS. Before making this choice, NASA reportedly considered several other companies for inclusion, including Gravitix, the exploration company, a European firm, and the UK-based GEPA Logistics. However, it seems none of these companies met NASA's specific requirements for the mission. The total value of the CRS-2 contracts is capped at $14 billion. NASA has assured that the extension will not exceed this budget. Federal databases show that as of now, NASA has awarded $2.7 billion to Northrop Grumman, $1.4 to Sierra Space, and $2.8 to SpaceX for a total of $6.9 billion. The choice of these 3 companies makes sense given their proven track records for ISS resupply. SpaceX's Dragon and Northrop Grumman's Cygnus have been operational for many years, with Dragon's most recent mission being CRS-31. Dragon is also the only U.S. vehicle currently transporting NASA astronauts to the ISS. As for Dream Chaser, although it has yet to launch, it shows strong potential for future missions. This also represents a significant setback for another vehicle, Starliner. After facing numerous issues following its crew flight test, it is still under review and its future schedule remains unclear. The delays have caused considerable losses for Boeing, which has suggested launching cargo missions as a way to offset the costs. However, that opportunity may be slipping away. It's clear that no one would risk using a vehicle with so many uncertainties for resupply missions, especially since these missions are crucial to the ISS's operations. Could this be the end for Starliner? Let me know your thoughts in the comment section down below. Now let's turn to an exciting update from NASA regarding a new telescope. At NASA's Jet Propulsion Laboratory in Southern California, engineers recently completed the successful integration of a key component into the Roman Space Telescope, the Roman Coronagraph instrument. This technology can block out starlight, enabling the telescope to detect the faint light emitted by planets outside our solar system. The Roman Space Telescope is currently scheduled for launch in May of 2027. With a field of view at least 100 times larger than that of the Hubble Space Telescope, it will focus on exploring mysteries related to dark energy, exoplanets, and infrared astrophysics. To achieve these goals, the telescope will use its primary science instrument, the Wide Field Instrument, alongside the Roman Coronagraph instrument, which serves as a technology demonstration for future space missions. This will be the first telescope specifically designed to search for signs of life on exoplanets. Rob Zellum, Deputy Project Scientist for Communications at NASA Goddard, shared, "In order to get from where we are to where we want to be, we need the Roman Coronagraph to demonstrate this technology. We'll apply the lessons learned to the next generation of NASA flagship missions that will be explicitly designed to search for Earth-like planets." The Roman Space Telescope's most notable technology is its coronagraph, which is roughly the size of a baby grand piano. This sophisticated system, made up of masks, prisms, detectors, and self-flexing mirrors, works together to block out the intense glare from distant stars, allowing scientists to detect planets orbiting those stars. Currently, telescopes use a technique called transiting, which requires a certain distance to observe faint or distant planets. However, the Roman coronagraph is designed to detect planets that are 100 million times fainter than their stars, making it 100 to 1,000 times more powerful than existing space-based coronagraphs, according to NASA's Jet Propulsion Laboratory. While it's not yet clear which vehicle will launch this telescope, with the 2027 timeline in mind, it's likely to be Starship. Given the progress SpaceX has made with its rockets alongside the capabilities of this groundbreaking telescope, we are on the brink of a new era in space exploration. The wait is almost over. Flight 6 is rapidly approaching, with steady progress and new confirmations from SpaceX and Elon Musk, making everything even more exciting. Meanwhile, Blue Origin has unveiled new hardware developments for New Glenn, though the launch date remains uncertain. And in China, a recently introduced NASA Space Shuttle replica is set to resupply the Tiangong space station. In just a few days, SpaceX will conduct its 6th Starship flight, marking the 4th this year as they rapidly push Starship development forward. Following the November 6th announcement, updates have highlighted the latest work on Ship 31, or S-31 for short, especially its heat shield. On November 11th, S-31 was rolled out, giving a clearer view of its redesigned tile pattern. SpaceX has reduced the heat tile count by over 1,000, bringing it from around 18,500 to 17,000. This change allows SpaceX to test new thermal protection materials and potentially add catch-enabling hardware for future recoveries. After a quick return to the high bay, S-31 was rolled back to the pad that evening, with SpaceX confirming on X, Starship moved to the pad at Starbase in advance of our 6th flight test. Elon Musk added, Starship Flight 6 is coming up soon in response, fueling anticipation. Now stationed at the launch site, S-31 awaits integration with its booster B-13. After completing a static fire in late October, B-13 returned to the production site for inspections, likely on its engines and grid fins, and now seems fully prepared. Observers noted modifications for hot staging, with a new staging ring spotted at Mega Bay 1 on November 8th, a key component for igniting Starship's engines before full booster separation, a strategy aimed at smoother stage transitions and fuel savings. With S-31 and B-13 nearly ready, this launch will likely showcase more of SpaceX's design innovations, particularly around reusability. SpaceX aims to reach a bi-weekly launch frequency by next year, and this flight brings them closer to deploying Starship for NASA's Artemis program and eventual Mars missions. As SpaceX continues pushing Starship's potential, Flight 6 is expected to add valuable data for refining reusability and high-frequency launch capabilities, further fueling excitement around SpaceX's ambitious vision for space exploration. With these final steps, B-13 will likely head to the launch site with its new crown, signaling it may not return to the production site. The B-13 rollout is expected within the next day or two. Once at the launch site, it will be stacked with S-31 to conduct a wet dress rehearsal test. Upon successful completion, the flight termination systems will be installed, setting the stage for a launch on the afternoon of November 18th. Meanwhile, on the 11th, the launch system itself underwent testing. Shortly before S-31 was rolled out, the flame deflector, or water deluge system, was activated in a full-capacity test, spraying 350,000 gallons of water. With no reported issues, the test was deemed successful. Following this, Musk confirmed Flight 6 is coming soon. Now, with all systems in place, final preparations are underway for launch in the days ahead. SpaceX will continue its steps toward the ultimate goal, Flight 6. Soon, we'll watch Starship soar once more, with Super Heavy returning to be caught by the chopstick system and the Starship stage igniting in space, re-entering and landing in a controlled vertical descent. Type "Let's run it back" in the comments if you're ready for the wild ride that'll ensue. Then, like, share, and subscribe to our channel to stay updated on SpaceX's development journey, especially as Flight 6 approaches. Indeed, Starship's rapid progress is putting significant pressure on its competitors, most notably Blue Origin, which has yet to launch its first New Glenn mission. After announcing the installation of 7 BE-4 engines on the first stage last month, Blue Origin has been shuffling the rocket between factories and company offices, but critical milestones like a hot fire test of the first stage are still pending. Instead, Blue Origin proceeded with the assembly of New Glenn's 2 stages. On November 12th, they shared images of the second stage outfitted with 2 BE-3U engines. CEO Dave Limp highlighted the power of these engines, explaining, "In the vacuum of space, the BE-3U's nozzles release hydrogen-rich steam at speeds of roughly 10,000 miles per hour. The vacuum nozzles measure an impressive 114.5 inches in length." Following this, Blue Origin revealed that they had successfully mated the first and second stages, stating, "GS-1 meets GS-2. We've mated New Glenn's first and second stages." With New Glenn's primary hardware now fully assembled, the rocket awaits only the arrival and integration of the fairing and Blue Ring payload. These steps suggest integration testing may be on the horizon. While the second stage completed its hot fire test in September, Blue Origin has yet to perform this test on the first stage. It's possible that they aim to conduct hot fire tests and wet dress rehearsals in rapid succession, a time-saving yet risky approach. Given the current pace, it seems likely that Blue Origin will begin integration testing by the end of this month, making a November launch improbable. This delay is not only about final preparations, but also the FAA approval process. Journalist Christian Davenport previously noted there is good progress toward getting an FAA launch license, but getting it in time for a November launch would be tight. Despite multiple reschedules, including moving the Blue Ring mission to New Glenn 1 and shifting the anticipated launch from December to November, the latest delay may push New Glenn's debut even further. Blue Origin has struggled to leverage SpaceX's Starship delays to its advantage. They initially aimed to launch before Starship's Flight 5, yet Flight 5 launched successfully, and now Starship's Flight 6 is likely to fly before New Glenn's inaugural launch, a significant setback. Should Blue Origin's upcoming tests encounter issues, New Glenn's first flight might be postponed to 2025, marking a notable setback for the company. The coming weeks will be critical. Let's see how Blue Origin responds, and if it can finally deliver on New Glenn's long-awaited first flight. Moving on from Blue Origin, we turn to China's latest ambitious imitation project. China's aerospace sector is shifting from imitation to innovation, marking a new phase in its space ambitions. Instead of directly copying SpaceX's rockets, China is now developing its own version of NASA's space shuttle, tailored to transport cargo to the Tiangong space station. The new spacecraft, named Haolong, is being developed by the Chengdu Aircraft Design and Research Institute, part of the state-owned Aviation Industry Corporation of China, or AVIC. This project is one of 2 awarded by China's Human Spaceflight Agency, or CNSA, for reusable, low-cost cargo transport, the other being the Qingzhou cargo spacecraft, designed by the Innovation Academy for Microsatellites of the Chinese Academy of Sciences, or IAMCAS for short. Up until now, China has relied on the expendable Tianzhou robotic spacecraft to supply Tiangong, but with a focus on reducing operational costs, the country has turned to reusability, taking a cue from NASA's own space shuttle program. Haolong bears a strong resemblance to the NASA shuttle, with similar contours, coloring, and wing design. Without Chinese markings, the images could easily be mistaken for the American spacecraft, emphasizing China's admiration for and adaptation of established Western designs, to put it lightly. Fong Yuanpeng, Haolong's chief designer, has provided insights into its distinctive design. The Haolong Space Cargo Shuttle is a winged aircraft with an aerodynamic design featuring a large wingspan and a high lift-to-drag ratio, Fong explained. He described a blunt-nosed fuselage and large, swept-back delta wings that give the vehicle both the structural characteristics of an aircraft and the functionality of a spacecraft. Unlike most modern rockets, Haolong is designed to be launched by a rocket into orbit and then returned by gliding to a runway, much like a traditional airplane. In terms of size, Haolong is smaller than NASA's shuttle, measuring 10 meters in length with a 8-meter wingspan, offering a more compact but similarly capable cargo transport vehicle. Currently, in the technical verification phase, Haolong's design is under rigorous review, with critical evaluations of its reusability, a key feature in China's cost-cutting and sustainability efforts for long-term space operations. Fong highlighted the reuse strategy as central to China's ambitions to sustain and even expand Tiangong. After inspection, maintenance, and repair, it'll be able to perform cargo transport missions again, Fong noted, indicating that China envisions a future where reusable spacecraft regularly transport goods and potentially crew to the space station. This strategy comes with risks. China's aerospace sector has previously encountered setbacks, especially with attempts to replicate Western space technology, as seen in earlier efforts to emulate SpaceX's reusable rockets. These projects, although promising, have sometimes encountered challenges stemming from the complexities of adapting advanced foreign designs into new contexts. Despite these hurdles, China's progress remains noteworthy. Haolong could indeed succeed as a fully reusable cargo shuttle for the Tiangong station, if the CNSA can manage the engineering and financial challenges associated with such an intricate space system. If successful, Haolong would significantly boost China's autonomy and sustainability in space, providing a cost-effective way to support Tiangong. Furthermore, the emergence of such domestically developed reusable spacecraft positions China to compete directly with other leading space agencies, potentially accelerating the global push for reusable spacecraft. The Haolong project underscores China's ambition not only to catch up, but to establish a significant presence in the space economy. While much remains to be tested and verified, Haolong represents a substantial shift from earlier replication strategies toward developing technology that serves China's own goals. With the project still in its early stages, it's too soon to determine whether Haolong will overcome the technical hurdles that have beset past copycat attempts. But with this step, China is undoubtedly signaling its intent to become a serious contender in the reusable space vehicle arena. Well, folks, that's about it for today's episode. Thank you so much for tuning in, and as always, this has been Kevin from Great SpaceX. Until next time, keep looking up.